Hi, welcome to ARISTOTHINK, and today I'm going to teach you, or at least show you, how to develop some proofs when you have to prove something, some formula. And what we're going to discuss now is going to be about polygons, okay? We have seen that whenever we have a polygon, let's put a polygon, let's start with a triangle, okay? We could start with any, a square, okay, a rectangle or an octagon, but let's do things simple, okay? I always like to start simple. Why? Because if the simple case works, it's safe to go to something else. Now, going to need that, the continuation of this site, and let's start. Let me take the pen. Okay, now I have all my pens with me, and now, well, what's the basic thing that we learned there? Well, I'm going to call the internal angles alpha, be alpha 1, alpha 2, and alpha 3. And the external angles, let's make all of them the external angles we're going to call beta. Beta 1, yeah, like this. So this is going to be beta 2, and now beta 3. Good. Well, what we know, there is a formula, right, to calculate the internal angles. And so, okay, but I know that the triangles, the internal angles is some 180. Yes, you do. But there is a formula, okay, to get the summation of the internal angles for every single polygon, and that is the formula. So the summation of all the alphas from 1 up to n sides is going to be what? Number of sides minus 2 times 180. So this is going to be the formula that we learn with respect to the internal angles. Well, there is also not a formula, but there is also a very simple way to calculate the internal, the summation of all the betas. And this is very interesting because it's a very easy formula. When you add all the external angles, it is just 360 degrees. And some people, they just say, why? And they just don't care about why is that so. And the purpose of this video is not to show you that how to prove that the external angles are going to add 360. The purpose of this video is to show you how you can prove something, okay, in math. So let's start with simple, okay? So the idea is just to prove, okay? So I want to prove to you that this statement, it is correct. Of course it is, but the idea is not to prove itself, but what is going to be the path, okay? And that is the whole thing, okay? What's going to be the path from here to here, okay? How do we go from here to here? And for that, I'm going to, let's start with this pen in here. Okay. Let's start with something very simple first. Well, first let's add all the betas, okay? We don't know it's 360 yet, okay? We're going to prove it. So let's start like this. So if we just add beta 1 plus beta 2 plus beta 3 plus beta n, okay? N betas. Well, what are we going to get in the end? It is just that, right? That's simple. Summation of betas from 1 all the way to the last one. And what's going to be? Is beta 1, beta 2, beta 3, beta n. But what is beta? Okay, let's try to put beta in terms of alpha. What is beta? Beta is 180 minus alpha 1 plus, what is going to be beta 2? 180 minus alpha 2, beta 3, 180 minus alpha 3, and of course all the way down, okay, there's some point in here, all the way down 180 minus alpha n. Well, what's going to be now? Let's just start to accommodate more the numbers, okay? Now, how many 180s are we going to have? Well, we're going to have as many 180s as many betas we have, and we're going to have as many betas as many sides we have. So we're going to have n 180s. Agree? Okay. In this case, we just have 3 sides. We have 3 betas. Therefore, we're going to have 3 angles. Now, now we just have a bunch of alphas. Alpha 1, alpha 2, alpha 3, etc. Alpha 1 plus alpha 2 plus alpha 3 plus etc. all the way to alpha n. Well, but what is that? What is this? What is this? This is that. Summation of all the alphas from 1 to n. We have a formula for this, right? It is just n minus 2 multiplied by 180. Now, let's just substitute that, because it doesn't matter to me alpha 1, alpha 2, alpha 3, okay? I can do anything with this bunch of Greek letters. Now, this is going to be 180 n minus n minus 2 times 180, right? I mean, just substituting things. Well, I have 180 in common. Let's put 180 in common. 180 is going to be n, right? Minus this one, minus this. So, minus n plus 2. Okay? Well, very simple to see that. We're going to cancel the n, meaning it's a very important thing here. It means that the external angles does not depend on the number of sides. And this is nothing else than 180 times 2, which is just 360 degrees. You see? So, in a very easy way, I could show you that the external angles, it doesn't depend. And if you come to think about it, okay, the more sides we have, that angle, I'm going to show you why is that so. This is triangle. Beta is very big. Now, let's, for instance, say the hexagon. 1, 2, 3, 4, 5, 6. Now, those are the continuations. Okay, so that will be beta. Beta, 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 and so on. Okay, now imagine we have a very big one, maybe one with 30 sides, okay? So, but the idea is this, can you see what is going on with alpha? Alpha is increasing, isn't it? Look, alpha in a triangle is very small. Why? Because the angles, like this, okay? The angles are small. As we just start to add, let's put it this way, okay? As we just start to add more and more angles, okay, or sides, alpha is going to increase, right? The more sides we put, the bigger it gets, alpha. Agree? Triangle, hexagon, if you put the heptagon, the octagon, we're going to increase alpha. But what's going on with beta? Well, we know that alpha plus beta, it must be 180. If alpha increases as n also increases, what's going to happen to beta? Beta is going to reduce, right? Okay, reduce as n increases. Now imagine a very big, okay, big polygon. So the sides are going to be basically 180, right? We're going to have something like that. okay, maybe one in here. Imagine, I don't know how big would be that polygon, but alpha is getting pretty big, close to 180, and beta is this one, is getting very small. So the more size we have in our polygon, beta goes smaller and smaller. So in the end, we are adding more betas, but they are getting smaller. So it's not going to grow beta. Okay, that is why beta is always 360. But what happens to alpha? Well, alpha is increasing enormously. Okay, the more n we have, the bigger the internal angles become. So it is just a way to show you why this formula increases for alpha, and for beta it remains the same. Okay, I just wanted to give you the idea that beta remains the same, because whenever we increase the polygon, beta decreases, and one compensates the others in a perfect way that in the end we're going to have exactly 306 degrees. Okay, so thank you very much. This is just an idea just to show you how to prove things. Okay, it's very easy to prove things, but it's not very easy to put it on paper. So thank you very much, and I hope you have enjoyed. Okay, comment and subscribe to the channel. Thank you.